Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and in today's video I'm going to do a little bit of tool making. Recently I was cutting some internal threads and kept thinking that the tool was just not cutting like it should, and got to checking and the height was way off on it. And I'm sure that's just come from not having checked the height in probably several uses. Let me grab one of the tool holders. As most of you are aware, there's the threaded stud in the top of the tool holder. And normally what you would do is put this on the quick change tool post, get the height set, and then turn this one to that position and then lock it down with the top one. And I guess what had happened in changing tools back and forth, the height had got off. And over the years I've had the lathe, I've simply used my height gauge to set the height of the tools. But I decided for today's video, what I think I'm going to do is try to make a height setting tool, something to be a little bit more permanent and hopefully a whole lot easier to use and set up. I've got this piece of brass here. It's 1 inch. I may look, before we actually get to that part, I may look over in my material bin. If I've got something a little bit larger diameter, I might use that, but this will work fine if not. First thing we're going to do though is put this, looks like about a 7/8 inch piece of aluminum is in my drop drawer, just something left over from another project. We're going to put this in the lathe and turn a point on this end. Purpose of that is to establish a good height for the center of my chuck. I know I could use the live center or dead center, either one, in the tailstock, but I want to try this method and see how that works. So let's turn to the lathe now. Alright, we'll put our aluminum drop workpiece here in the chuck. And again, I couldn't establish a height from the tailstock, but I like this method, or I want to try this method. Now what we want to do is slide the compound here over on the cross slide. I could cut the taper with it like this and the lathe in forward, but I like to cut it over here, like to turn it over here, push that to the back side and lock that down. That way I'm not reaching around here trying to cut in, trying to turn the compound. I'm working off the front of the lathe. Put the lathe in reverse. And hopefully you can see what's going to happen here. As I turn in here, of course, I'm going to be cutting a taper. I'm going to Alright, I can lock my cross slide down. Alright, let me get the compound out of the way, and I think you can see what I've done here. So what I have is the exact center of this chuck. Alright, now let's take the height gauge itself and measure the height. And I have already stoned this surface right here. Alright, I've got a good 0 on the height gauge now. And I'm going to turn this. Alright, I'm going to see if I can prop this clipboard up back here just to give a contrasting background. Alright, if I lock my height gauge down right here, I have a good established height, which in this case looks like 3.395. I believe that was probably meant to be 3.4. So we're finished with this now. I want to take this piece of brass. A friend of mine gave me several pieces, 10, 15 pieces of brass similar to this. They were drops from I guess a point where he worked at some time. Most all of them, the longer pieces like this, are a little bit mushroomed on the end where they've been used, I guess, for a punch. So let's clean this up. We don't need this anymore. We've established our height. Alright, so that tool height was 3.4 inches. So we know we need at least that much of this piece of brass. But we also need enough for the cap that's going to turn over. We're going to turn to the side to give us our height. There's a little over 4 inches sticking out. So I'm going to very lightly dress this piece for about 4 inches here. That didn't quite clean that up down here on the end, but I think I need to face it first and then clean that last little bit up. And I'm going to slow the feed rate down some too. That was leaving a little bit of a ridge there. We'll try about another 10 thousandths. That's feeding about a 2.5 thousandths per revolution, which is leaving a much better finish. Oh yeah, that's much smoother finish. I think though, before I part that off, I'm gonna polish it just a little bit more with a piece of emery. Alright, let's double check and be sure we're square with the workpiece. Alright, I'm just going to use the micrometer right now and line that up edge with the end, zero out the DRO. Pull that out just a little bit and part off every bit I cleaned up. That's going to be a little long, but we're just wanting to get our workpiece close right now. Alright, this will go back in the drop bin for a later project. And even though this is a rough length now, I'm going to go ahead and face off this end we just parted from. It goes without saying, no matter how good you got your height set on the tool, if they swarf up underneath the tool holder, that kind of negates everything you did with setting the height of the tool. Alright, we're going over to the mill now, and what I'm going to do is use the coaxial indicator and get the mill set up directly over the center of this. Then we're going to offset about 2/3 of the radius and drill and tap for probably a 1024. We'll do all that before we part off what is going to be our cap up here. And once we get that parted and get these two surfaces mated together, we'll work on the rest of this of getting it to that exact 3.4 length. Alright, to hold our workpiece vertical in the mill vise, we're going to use this V-block that I made, I don't know, several years ago. If you recall from that video, the screws that hold this vice jaw in place, I actually drilled and tapped them so that I can mount this semi-permanently in place. Now most of the time I don't bother putting these screws in because it's a quick use and done with it. But in this I may need to come back to center. I'm not sure, so I'm going to go ahead and screw it in. Okay, so once I find center now with the coaxial indicator and zero out my DRO, I should be able to come back to it should I have a need while we're working on this same workpiece. I'm going to get the coaxial indicator hooked up and bring you right back. Okay, I've got the workpiece mounted in the vise now in the V-block. It's held vertical by the V-block itself. Got the coaxial indicator mounted up here in the quill, and I've got it close, or I've got it to where the indicator will rotate all the way around. Got it set on one side here and got this about zeroed out. I'm going to swing it to the other side. Alright, we'll manually bring this back about half that distance. All I'm doing now is just trying to get this reasonably close. So we're reasonably close on the x-axis now. So let's turn to the y all the way around. That's way close. Hopefully you can see here in the camera, there's an arm coming off the coaxial indicator that's bumped up against this shield back here, and that just helps hold it in place. So we'll put it in low range. Now let's start with our x-axis and see if we can calm that needle down any. Just have to experiment to try to see which way to go. Alright, that's calmed down some. Let's try the x-axis a little bit, or y-axis. And it doesn't matter where on the dial that the needle settles down. We just want it to settle down as very much as possible. All right, I was adjusting the Y then. Now let's go back to the X. That's within a half a thousandth right there. Very, very little movement on the needle now. So I'm going to call that centered. I'm going to zero out the DRO on both axes. I'll take this out of the way, and then I'll calculate how much I want to move over. What I'm wanting to do is pretty much line the head up of a 1028 with that edge. We'll drill and tap that. Then we'll go back to the lathe and part off one section of this. Maybe 3/8 to a ½ inch of it. All right, I measured the diameter of our workpiece and that come out to 0.980. Half of that is 490 thousandths. The head of our screw that we're going to use, and where did I set it down? Here we go. And the head of the screw we're going to use, diameter of that is 300 thousandths. So half of that is 150. So the radius 490 minus the radius of this, which was 150, gives us 340 thousandths offset. All right, now we'll get our tap drill for the 1024. And I'm going to drill this plenty deep. All right, that's about an inch deep, which should give us plenty of room now for the cap that we're going to cut up here and then thread down in the bottom. All right, I don't think I'm going to power tap this. I want to get the tap guide and put in here and then come back and we'll hand tap this. I'm sure most of you are familiar with the way a tap guide works, but it just fits up in the chuck. Put your tap in a tap handle that has a center in it. And this pin is spring loaded. Bring it down so that you got tension on it. I'm really not sure what kind of lube you're supposed to use on brass. I'm going to use just my standard threading lube. I'm using a 2-fluted taper tap here. Now once you run out up here, of course, bring it down more. All we did was load that spring back up again. And that's probably about as far as that's going to go. All right, I'm going to take this taper tap out and put a bottom tap in. See if we can get a little siphoning effect. Now the threads in what's going to become the cap right here, the threads will be drilled out of it. May have to go with a little longer screw. But let's turn back to the lathe now and part off what's going to be this cap. Alright, back at the lathe now. Put our workpiece back in. And we'll take our parting tool, excuse me, our parting tool once again. And set edges together. Zero out the Z-axis, and I think we're going to make our cap about a 3/8 inch. All right, I know that's going to leave a little tit on there no matter what I do, so I'm just going to break that off. Well, I broke it off to keep from dropping it, and dropped it anyhow. All right, let's clean that face up just a little bit on this end. Now this piece will be to machine down the length. Probably have to clean out those threads right there a little bit. But let's see if we can get this piece in straight enough to clean that little tit off the end of it. All right, I'm going to turn to the workbench right quick and put these pieces together. Be sure they work together. And then bring you back and show you what I've got. Again, I may have to clean out these threads just a little bit here. Then we'll work on getting this machine to the exact length. Okay, over at the workbench, I drilled out the threads in what we're calling the cap here so that it pivots easily over this 1024 screw. Now, if you haven't figured out what we're doing so far, here's the way this will work. This will set on the cross slide down here and kick out. Now the top of this is within, I suspect, a 1/2 thousandths, 5/10 of the bottom of that. I can always tighten that screw down as I'm setting up. This is for storage. We'll swing that out, and all right, she's tight. And the way that will work, this has to be machined to that exact height that we come up with at the beginning of this video, which was the 3.4 inches. But what we'll do is put a tool in the quick change tool post, swing it around where we got access to it, and keep adjusting the height right here until it just touches the bottom. As I say, this has got to be machined to length now. So I'm going to take this back off. We'll go back to the workbench and I'll get a mark on this. This end will stay the same, and we'll just keep turning, facing off this end down here until we get that exact height. Okay, if you remember when we originally cut this off, we cut it long enough, of course, to have the cap here. And we also added just a little bit extra. The height gauge is still set at the 3.4 inches, which was the height from the from the cross slide to the center of the, or to the point on this piece we turned. So now let's mark this. I've got my surface plate here. Alright, so we've got a wetness mark on here. We can go back to the lathe, and it's not enough to part off, I don't think. We'll just keep turning this down until we got this piece here exactly 3.4 inches. Alright, I've been advancing the compound in to make those cuts. We're getting close now. So I'm going to swing I've still got my cross slide locked down. I'm going to set the compound at 90 degrees, or on this indicator it'll be 0. Alright, I'm going to take the workpiece out now and measure that and see how much we got left to go. Then we'll touch this off and use the dial here on the compound to get our last few thousandths in. Alright, we're at 3.444. So we need 44 more thousandths off the end down here. Alright, that's just touching. I will zero out the dial on the compound. And here is 40. And that looks like it's right on the line. I'm going to measure that before we take that other 4 thousandths off. That is right on the money. I can't do any better than that. The compound may not have been at exactly perpendicular to the workpiece. That's where that extra 4 thousandths may have come in. But we're good right here. Now let's go over to the mill and do one more step on this. Alright, we've got our workpiece to our exact height now, 3.4 inches. One more thing I want to do to it is countersink this little button magnet in the base of it. That'll help hold it in place. These are not really all that strong, but that will help hold it while I'm setting a tool height. Now remember, we set our DRO to 0 with this V-block mounted to the vise, so it couldn't move. So we'll come back to 0 on both axes now. And let's touch this off. Alright, there's 0. Magnets are 115 thousandths thick. Actually, they're 110 thousandths thick. But I want to give a little extra, and it looks like the workpiece slipped down in the vise just a little bit. And that is below the surface. Alright, I'm going to glue that in, and then I'll clean off the die cam, glue that in, then we'll meet back at the lathe just for a very quick recap. So stick with me. Okay, as I said earlier in the video, the cap in this position is just primarily for storage. We can swing it out. Feels like there might still be a burr in them threads. I'll double check that. But the magnet under the bottom, of course, helps it stand in place. And then we just work that over or bring that over the point on our tool. If it needs adjusting, of course, we adjust these back and forth. Now I saw this style height gauge or height setting tool somewhere on one of the YouTube videos several years ago. And if I could remember who it was that did that, I first saw that, I would gladly give him credit. I don't remember it. I almost want to think it was Tom Lipton. But in any case, I hope you guys got some enjoyment out of this video. See how this works. I've got several tool holders I need to double check the height on, and also several of them that I probably need to index the insert around. You guys take care, and I'll see you on the next video.